Hi, everyone. So yesterday we started looking at solving systems of linear equations using those three operations. So we said that we could add or subtract any of those two equations. We could swap equations around. And lastly, we could multiply or divide equations by some constant. And then using those operations, we could turn a given set of linear equations into something that looks like the following. So let's say we had 2x plus 3y is equal to 1, x minus y is equal to 2. So that's what was given. And if you perform certain operations, we could turn this system into x equals something, y equals something. Okay, so we could manipulate the system of equations so that we end up with the solutions at the end. Okay, and then the three operations, let's just summarize those. Okay, those were swap any two equations, multiply or divide an equation by a constant. Okay, and lastly, add or subtract any two equations. Okay, so those were the three operations that we allowed. So what we're going to do now is look at a different way of writing out these equations that's a bit neater. Okay, and it allows us to do our operations without having to rewrite the equations all the time. Okay, and this method of writing it neater is called an augmented matrix. Okay, so a matrix is just like a table. So you've got rows and you've got columns, and then in each cell of the table, you can put some value. So what we're going to do is we're going to put these coefficients of the variables into those cells. Okay, so let's say we have the system of equations, 2x plus 3y is equal to 1. X minus y is equal to 2. So in front of the x and the y in the second equation, remember there's like an invisible 1 there. So you've got 1 and you've got 1. So what we're going to do is take this system and rewrite it in a small table. So it's going to look like this. Okay, so we use the square brackets just to show the table. The first entry is going to be this coefficient of x in the first equation. So you can think of it as the rows are the equations, and then the columns are going to be the coefficients of x, y, and later on we'll see z. Okay, so that's going to be a 2. Okay, for the next one, we're still in the first row. So we're still in the first equation, but now we're looking at the y column. So that's going to be a 3. There's a 3 there. Yeah, and then we're done with the variables. So now we're up to the equal to sign, and we put a vertical line. Okay, so we put a vertical line there. So that means the equal to sign. And then lastly, we put this constant, that's a 1. So we put the 1 there. Okay, so that's the first row done. Okay, and then you can close it like that. Next, we look at the second equation, which corresponds to the second row. So we've got a coefficient of x being 1. So we put a 1 there. Then we look at the coefficients of y, that's a -1. So we put a -1 there. Okay, then we got the equal to sign, and then the constant at the end, that's a 2. So we put a 2 there. Okay, so again, the rows correspond to the different equations that we have. So equation 1, that becomes row 1. So this was equation 1. This now becomes row 1. The next one is equation 2, so that becomes row 2. Okay. Next, if we look down the columns, we see that the first column corresponds to x. So that's x. And then the second column corresponds to y. That's going to be y. And then the third column, you don't need to write anything because those are just our constants. Okay. So this thing now on the right, we call this an augmented matrix. Okay, so that's what we're going to use now. And the nice thing about the augmented matrix is we can do exactly the same operations. However, we don't need to write the variables every time. So as long as we keep it in the rows and the columns, we know what goes where. So we know that the rows correspond to equations and the columns correspond to the variables. So we've got the x column, the y column. We'll see later we have the z column. Okay, as long as you keep that order, then everything is fine. Okay, so now that we've got this augmented matrix, these operations that we had before for the equations now become what we call row operations. Okay, because we do them on the rows, because the rows mean the equations. So now we have row operations. Okay, so the first operation was swap any two equations. Now the first row operation will be swap any two rows. Yeah. The next one was multiply or divide an equation by a constant. So here we're going to multiply or divide any row by a constant. Okay, and the last one, add or subtract any two equations. This is going to become add or subtract any two rows. Okay, so you see we've just replaced equation with row. Everything stays the same. Okay, and we call these the row operations. These are very important to know. Okay, and we're going to do exactly the same thing as before. Remember last time we had equations 1 and 2. The first equation we wanted to manipulate so that it was x equals something. And the second equation we wanted to manipulate so that it was y equals something. We're going to do the same thing here. Okay, so let's try and solve this using the augmented matrix and row operations. So we start off with the augmented matrix. So it's going to be 2, 3, 1. 1 minus 1, 2. Okay, and we're going to do our row operations now. So remember what we wanted. We wanted the first equation. So now we want the first row to have the coefficients of x being 1. Okay, we just want x equals something. So that means that this first entry here, we want this to be a 1. Right? Because that means x has a coefficient of 1. And we also want this next one to be a 0. Because that means in our first equation, we have x and we have no y, plus 0y, and equals something. Okay, and then the same thing for the next row. Let's do a different color. This we want to be a 0. Because in the second equation, we don't want any x terms. So that means the coefficients of x must be 0. And lastly, we want this to be a 1. Okay, because then that will give us y equals something. Okay, so that's the goal. Okay, so in the end, we want it to look something like 1, 0, 0, 1. With our solution, if you remember from last time, was 7 over 5 and minus 3 over 5. Okay, so that is our solution as an augmented matrix. We can write this as a system of equations again, because remember the first column was x, the second column was y, the first row was our first equation, the second row was our second equation. So this means x equals 7 over 5. And for the second row, that means y equals minus 3 over 5. Okay, so this is what we are aiming for, something that looks like that. And we are going to get there using our row operations. Okay, so I hope that makes sense. We're going to get from the first, from there to there, using row operations. Okay, so let's see what row operations we need to do. Okay, so let's start. So we have 2, 3, 1, minus 1 with 1 and 2. So remember, we need this 2, we need it to be a 1. So what can we do? We can either divide the row by 2, that will make it a 1. But then we're going to be working with fractions because we're going to have 3 over 2 and 1 over 2. It's best to avoid fractions, right? Adding and subtracting fractions, that can get a bit messy. So what we could do is we could take this row 1 and subtract row 2. So we're going to take row 1 and subtract row 2 because the 2 minus 1 will give us the 1 that we need. Okay, so let's perform that row operation. So 2 minus 1, that's going to be 1. 3 minus 1 will be 3 plus 1, so that will be 4. And 1 minus 2 is minus 1. And then we're left with 1 minus 1, 2. Row 2 stays the same because we never did anything to that. Okay, we only changed row 1. Okay, so that's done. We can highlight that in green. It's a 1, so we're fine. We're done with that. Next, what we want is everything below the 1 to be a 0. So this number here, we don't want a 1, we want that to be a 0. So what can we do? We can take row 2 and subtract row 1. Because they're 1 minus 1, that will give us a 0. So we're going to take row 2 and subtract row 1. Okay, so that means the first row stays the same. We can just rewrite it. 1, 4, minus 1. Okay, so 1 minus 1, that's going to be a 0. Minus 1 minus 4, that's going to be a minus 5. And 2 minus 1, that's 2 plus 1, that's going to be a 3. So notice how row 1 stayed the same because we only changed row 2. Okay, so that stayed the same. Okay, good. Next, okay, so that's done. So let's highlight that. So we've got a 1 there, that's good. We've got a 0 there, that's good. Remember what the next thing was? If we go back up here, this bit over here, we want that to be a 1. So we need to do some row operations to get that to be a 1. Okay, but we don't want to change what we've already done. Okay, we've already got the first entry to be a 0. We don't want to change that. So what can we do to turn the minus 5 into a 1 such that we don't change anything else in that row? We don't want to mess anything else up. So what we can do is we can take row 2 and divide by minus 5. Because that will change the minus 5 into a 1 and it won't change the 0. We've already done with that. We don't want to change that. Okay, so let's do that. So we're going to get 1, 4, minus 1, 0, 1, and then minus 3 over 5. Okay. So now we've done 3 things. We've got that to be a 1. We got this to be a 0, and we've got this to be a 1. There's one more thing that we need to do, and that is change this 4 to be a 0. Okay, we want this to be a 0. Okay, so what can we do? Well, we don't want to change the 1, so we don't want to be dividing or multiplying by anything. But what we can do is take row 1 and subtract 4 times row 2. Row 1 minus 4 times row 2. Because look at the entry in row 2, that's a 1. If we have 4 minus 4, that's going to give us a 0. Okay, so we're going to do that. So we're going to have 1, 0. Okay, because the 1 minus 0, that's 0. 4 minus 4, that's 0. And then we're going to have minus 1 minus 3 over 5 times 4. So minus 1 minus 4 times minus 3 over 5. Okay, so we can just leave it like that there. And then we have 0, 1 minus 3 over 5. Okay, now if we work that out, the minus 1 plus 12 over 5, if you work that out there, that's going to give us 7 over 5. So that's 1, 0, 7 over 5, 0, 1, minus 3 over 5. And we're done because we've got the 1 and the 1 along the diagonal. So that's what we call this here. So this bit over there, we call that the diagonal. Okay, because it's the diagonal part of the square. Okay, and then the zeros here, we call that the off diagonal because it's the numbers that aren't on the diagonal. They're off the diagonal. Okay, so we've got 1s along the diagonal. We've got zeros on the off diagonal part. So we're done. Because if we look at this back as a system of linear equations, this is written as x plus 0 times y is equal to 7 over 5. Oh, there's a 1 there. The second row, we can read it as 0 times x plus 1 times y is minus 3 over 5. But that's exactly the same as saying x is equal to 7 over 5 and y is equal to minus 3 over 5. We have our solution. Okay. So that's the process that we use with these row operations. So let's just go through that one more time. Okay, so we've got our original augmented matrix, which we write from the system. Okay, so let's use a different color. So the first thing that we need to do is get this first entry to be a 1. That's the first thing we need to do. So first, get this to be a 1. That's step 1. Step 2 is to make everything below that entry a 0. That's this bit over here. So if you're working with the 2 by 2 grid, then there's only going to be one thing below it. If we're working with a 3 by 3 grid, then there's going to be 2 things below it. Okay, so we'll look at the 3 by 3 now. But just remember, everything below that 1, that needs to then be a 0. So let's make a note here. So second, everything below the 1 must be a 0. Okay, so that's the second thing that we need to do. Okay, and we just repeat this process for the next entry. However, for the next column, we're not dealing with the first one, we're dealing with the second. So we've got the second one there. So that needs to be a 1. So third, the second entry in the second, so the second column, second row, maybe I should write it like that. Okay, so the second column and second row entry must be a 1. Okay, because we're dealing with the second column now. So we do the second column, second row. Okay, and lastly, we want everything else. So we've already set that value to 1. Everything else must then be 0. So all the other rows must be 0. So that's the fourth thing. All rows above and below all rows above and below in that column must be 0. Okay, so that's the general idea of what we're trying to do. Okay, so let's have a look at a 3x3 example, and then that has more row operations, so you can see what needs to be done. Okay, so let's say we have the following. So we have x plus y plus z is equal to 6. Okay, so now we have 3 variables. Then we have 2x minus y minus z is equal to minus 3. And 3y minus 2z is equal to 0. Okay, so you see we've got ourselves an x column. Okay, x column going down. We've got a y column. And we've got a z column. Okay, but notice in row 3 or equation 3, there's no x term there. However, we can introduce an x term just by saying 0x and then plus. Okay, so we haven't changed anything, but we need that 0 so that we can write this as an augmented matrix. So this is going to look like 1, 2, 0 for the x column. Okay, there's a 1 there. There's a 1 there. There's a 1 there. Okay, there's 1s in front of everything if there's no 1. Okay, so 1, 2, 0. The next one is 1 minus 1, 3. And the z column is 1 minus 1 minus 2. Okay, we put the line where the equal signs go, and then we have 6 minus 3, 0. Okay, so that is our augmented matrix. Okay, good. So now we just follow the steps. So we look at row 1, column 1. This element here needs to be a 1. Okay, that's our first step. It's already a 1, so we don't need to do anything. So we move on to the next steps. And that is everything below that 1 needs to be a 0. So this needs to be a 0, and this needs to be a 0. Okay, so now the second one is already a 0, so we don't need to worry about that. But that 2, we need to make it a 0. How do we do that? Well, we're going to take row 2 and minus 2 times row 1. Row 2 minus 2 times row 1. That will cancel the 2. Okay. So let's do that. Okay, so the first row stays the same. 1, 1, 1, 6. Okay, but now we're going to take row 2 and subtract 2 times row 1. So 2 minus 2, that's going to be 0. Minus 1 minus 2, that's going to be minus 3. Minus 1 minus 2, that's going to be minus 3. And minus 3, okay, so just look at the last one here. So we're going to have minus 3 minus 12. Okay, because it's minus 2 row 1. So that's going to be minus 15. Okay, and then the last row, it already has the 0 there, so we just leave it alone. Okay, and we are now done with the first column. So you can put a little tick there. We're done with the first column because we've got 1, 0, 0. As soon as it looks like that, we're done. Okay, now we look at the next column. We want the second entry, the second row, second column, that's this. We want that to be a 1. So we want this to be a 1. And we want everything above and everything below to be a 0. We want that to be a 0, we want that to be a 0. Okay, so what do we need to do? How can we get this minus 3 to become a 1? What we could do is divide the row by minus 3. That will turn it into a 1. So we are going to take row 2, divide by minus 3. Okay, so let's do that. Okay, so our first column is done. We don't need to worry about it anymore. That's 1, 0, 0. We're going to have 1, 1, 6. We're not interested in the first row. We're looking at the second row. 0 divided by minus 3, that's 0. Minus 3 divided by minus 3, that's going to be 1. Minus 3 divided by minus 3, that's 1. Minus 15 divided by minus 3, that's 5. And that's it. Okay, the third row, that stays the same. Okay, good. So now we've got this to be a 1. Next, the entry above and the entry below needs to be a 0. So this needs to go away and this needs to go away. Okay, we want those to be zeros. So what can we do? Let's look at the top one first. What we could do is take row 1 and minus row 2. Then the ones will cancel. So we're going to take row 1 minus row 2. That will turn the 1 into a 0. Okay, so let's do that. 1 minus 0, that's 1. 1 minus 1, that's 0. 1 minus 1, that's 0. 6 minus 5, that's 1. Okay, good. The second row, that remains the same. 0, 1, 1, 5. And the third row, that remains the same. We never did anything to the third row. So that's 0, 3, minus 2, minus 2. Okay, good. So let's look at our progress so far. Okay, so the first column, that's done. It's 1, 0, 0. We don't need to worry about it anymore. Let's look at the second column. The second row, second column, that's a 1. That's done. The value above is a 0, which is what we want. That's done. We look one below, and that's a 3. Okay, we want this to be a 0. Want that to be a 0 there. So what can we do? We can take row 3 and minus 3 times row 2. Okay, because if we do that, then the 3 that are highlighted in yellow will cancel with 3 times 1, which is just above there in green. Okay, so let's do that. So we're going to have 1, 0, 0. That stays the same. 0, 1. Okay, so 3 minus 1, that's going to be 0. And now we're going to have minus 2 minus 3. So minus 2 minus 3, It's going to be minus 5. Okay, these other ones stay the same. That stays the same, 1, 5. And then we're going to have minus 2 minus, over here, minus 2 minus 15. Let me just check here. Yeah, so we're going to take this minus 2 and minus 3 times row 2. So it's going to be minus 2 minus 3 times 5. So minus 2 minus 15 is minus 17. Okay, so again, let's look at our progress so far. Column 1, that's done. Let's look at column 2. The second row, second column, that's a 1. Okay, that's good there. If we look at the one above, that's a 0. The one below, that's a 0. So that's all done now. So tick and tick. Now, if we look at the third column here, what do we want to do? Since it's the third column, we now want the third row, third column to be a 1. So this minus 5, we want it to be a 1. And everything else we want to be a 0. So we want this to be a 0. We want this to be a 0. Okay, and if you go and perform those row operations, then we end up with, okay, so we're just running out of time. So I'll just give you the final answer here. So we have 1, 0, 0, 1, 0, 1, 0, 2, and 0, 0, 1, 3. Okay, if you go ahead and perform those row operations. So we've got these 1s along the diagonal. So that means the first row corresponds to x equals 1. The second row corresponds to y equals 2. And the third row corresponds to z equals 3. Okay, so we get x equals 1, y equals 2, and z equals 3. Okay, which is what we wanted. Okay, and then just the off diagonal bits here. Remember, those must all be zeros. Okay, so that's basically the process involved. So we want, just quickly to go over this again, we want this first entry here to be a 1. Everything else below that, we want that to be a 0. So all of the stuff here, we want those to be zeros. Then you move on to the next column. We then want the second row, second column. So you just move along the diagonal. The second row, second column, we want that to be a 1. Everything above, everything below, we want that to be zeros. So it's zeros there, 0 there. Okay, and then once that's done, we move on to the next column. Okay, so third column, so we want the third row, third column, we want that to be a 1. Everything above, we want those to be zeros. Okay, so once it looks like that, then everything in this last column, that's our solution. So the first row corresponds to x equals 1. The second row corresponds to y equals 2. And the third row corresponds to z equals 3. Okay, are there any questions so far? Okay, so it's not too bad. As long as you follow those steps, then you'll get to this form over here. And then you can just read off your solutions. Okay, so I will post today's homework in the class WhatsApp group. And then you can post your solutions on Learn 2022 under the homework submissions. Okay, someone's asking, how did we get 3 from 17? Let's just check that. Might have made a mistake here. 3 minus 2, 0. Oh, sorry, that's supposed to be, thank you for spotting that. This is supposed to be a 0. Okay, because we've got a 0 here, so that's a 0 there. Then this is a 0 here. Okay, then that's a 0 there. Okay, and then when we minus the 15, that becomes a minus 15, not a minus 17. Okay, and then the minus 15, that becomes the minus 3 when we divide by minus 5. Okay, so, sorry. That last one there, that's going to be the minus 15 divided by minus 5, and that gives us our 3. Cool. Thank you for spotting that. Okay. Any other questions? Okay. Just one note, when you're doing these for homework or the tutorials or the tests, this stuff on the side here. Okay, so remember when we wrote row 2 divided by minus 3 or row 1 minus row 2, please make sure that you write down the steps that you're following. Okay, so any row operations that you perform, please make sure that you write it on the side. Okay, so that I can see what you're doing. Okay, so don't just write down the augmented matrices one after the other. You do need to include which row operations you've been doing. Okay, it just helps me see what you've been doing, so I can give you part marks, as you go through with the steps. Okay, if you do have any questions later on, please let me know on the WhatsApp group, or you can send me an email, and then I will post today's homework on the WhatsApp group, and then you can send me your solutions via the homework submission button. Okay. I'll see all of you tomorrow. Bye, everyone.